Okay, the transfer function is a standard representation that we use in control engineering to model systems. What goes inside the block in that block diagram is a system transfer function relating the output quantity to the input quantity. Okay, and it's traditionally labeled up as G, transfer functions in a forward path of G, and they're always defined as output over input equals some expression. So what we get to is a very simple format relating the output of the system to the input. Okay. They're not perfect. Transfer functions have got a few drawbacks. For what we're doing, which is kind of introducing you guys to control, they're fine. But they do have some drawbacks in the sense that you can only ever relate one input to one output at a time. If you've got a more complex system with multiple inputs and multiple outputs, you need lots of different transfer functions. And we would tend not to use the transfer function method for that. But for what we're doing, this is great. This is a good way to start. This is a mass spring damper with just a force input. Output over input is 1 over, in this case it's a quadratic. Seen that before? Produced that equation in the tutorial, most of you I think. Okay, Q in, that should be capital R. No, this is a time one, I'm safe for the minute. Q in equals cross-sectional area times the rate of change of depth plus some constant of proportionality times the depth of water. Yeah, you've all done that one in the first tutorial sheet. Transform it and rearrange to give me output H over input Q in. And it ends up looking 1 over K plus AS. Remember that pattern.